bullet is fired straight up in the air at a speed of 900 meters per second. The equation relating its height as a function of time is h equals, they're using height now instead of s, that's fine, whatever, minus 4.9t squared plus 900t plus 2.4. This number is one you probably have seen before. This is the Earth's gravity rating, if you will. It's how strong our surface field is. So it's how hard gravity pulls on objects near the ground. This, of course, is the 900 meters per second they mentioned. It's the velocity the object starts with. And the 2.4 would be the initial height, because if a person holds a rifle, they didn't say rifle, I'm assuming rifle, and, oh, sorry, firing straight up, so that angle isn't appropriate. If you hold it pointing straight up and fire it, it's probably a little higher up than your head. Hopefully you're not popping it off right next to your ear. And so that 2.4 is the starting level before the bullet begins to rise. And of course, when you do that, here's our person in miniature, the round is going to rise for quite a while, but eventually it's going to slow down, and then it's going to peak right there. That's a point called the apex. And then it's going to start falling back down. Faster, 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 until it hits, hopefully, the ground and comes to a halt. So if we have this equation and they're asking about how long the bullet takes to hit the ground, well, that'll be when the height is 0, and that means it's quadratic time again. Minus 4.9t squared plus 900t plus 2.4 equals 0. I've been multiplying these by minus 1 every time. I'm going to not do that once just to prove to you that it still works. So, quadratic formula, minus b. And plus or minus. We know one of these answers is going to be junk, probably the negative one, but I'll leave that in too for now. Plus or minus root. B squared is 900 squared, which is 810,000, I believe. Minus 4 times a times c, delightful number, all over 2 times a, which is minus 9.8. Okay, so the plus or minus means do this whole calculation once with a plus here, then do it all again with a minus here, and that'll give you 2 different answers. So if we do the plus, minus 900 plus, let's work out this radical, 810,000 minus 4 times minus 4.9 times 2.4 gives me 810,047, which is a little ridiculous. I could have almost ignored that. So we get minus 900 plus 900 0.03 divided by minus 9.8, and that ends up being 0.03 divided by 9.8 negative. Okay, so one of our answers comes out to minus 0.003 seconds. And if I do this again with a minus, I get minus 900 minus 900.03 all over minus 9.8. And that comes out to 1800.03 divided by 9.8, 183.7 seconds. So what does this mean? Well, as before, as far as the math is concerned, this bullet's been following a parabola forever, all the way to the right, and forever to the left as well. And so it thinks, even though right here at 0 is where the bullet started flying, that 0.003 seconds before that, the bullet was at ground level. It thinks the bullet came busting up out of the ground and up into the air and then continued on this parabola. So this is the nonsense answer, because the bullet didn't come up out of the ground. It was sitting in a firing chamber until someone pressed the trigger here. So we can ignore that answer. The other answer, did you think it would be this high? We're ignoring air resistance here, which is a pretty large fudge when you're talking about bullets, but still, this says this bullet is going to take over 3 minutes to get all the way up into the air and then come all the way back down. I believe the actual times are lower than this because the bullet dumps a lot of energy in the first little while getting through the air. It tends to not rise as high, and then it loses a lot more speed, a lot more energy on the rise than it does on the fall, so it spends much less time than this in the air, maybe more like a minute. But if there were no air resistance, this is how long a bullet would hang before coming back down. Now, 900 meters per second is a pretty wild muzzle velocity for a bullet, but it's not completely out of the question. And this says that's how long it would take to get from here to the top and back down. Maximum and minimum values for the velocity. Well, if we're going to talk about velocity, we need to quickly do a derivative here. The derivative is dh dt, or h prime if you want, and it should be minus 9.8t. I'm doing this with the power rule, so 2 times minus 4.9 is minus 9.8 t to the 1 plus 900. So if you're this bullet, for velocity, you're thinking, I start with 900, but gravity is going to take away 9.8 meters per second from me every second. I'm going to rise slower, 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 until I get to the top, and then my velocity is actually going to go negative as I fall down faster and faster. So our maximum velocity is actually the 900 that we had right here. So we start going upwards at plus 900 meters per second. The velocity falls. The velocity is actually 0 for just an instant at the very top. The bullet rises slower, 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 stops, and then begins to fall back down. So the minimum velocity you could think of as 0. It actually freezes in the air for just a second and then falls back down. Now, on the way back down, it starts going faster and faster and faster. And just as it hits the ground, well, we know that's going to take 183.7 seconds. The velocity there should be minus 9.8 t plus 900. And if we crunch that out, minus 9.8 times 183.7 plus 900, and we get minus 900.26, according to my calculator, meters per second. So it had 900 coming out of the barrel. It would fall back down and be going 900 meters per second as it gets back to that exact same height, and then falling just that little bit further, the extra 2.4 meters to the ground, enables it to pick up just a little bit more speed. So it'll hit the ground ever so slightly faster than it came out of the gun. And question C, which I scrolled off the screen. But what it says is, what is the velocity of the bullet after 60 seconds? Well, this formula works for the velocity anytime, so except negative times when it gets confused. So minus 9.8 times 60 plus 900 equals, grabbing calculator, plus 900. I get an answer of positive 312 meters per second for the velocity after a minute, which would mean we're somewhere up here on our trajectory, going much slower, but definitely still rising. Got a ways to go before we get to our stopping point. After that, the velocity will go negative and then get bigger and bigger and bigger until we thump into the ground.